Homework number 6 now. Unit 2, homework 6. So write the decimals as fractions and then add. So this is kind of a funny thing. They want me to take these decimals, write them as fractions, and then add them up. Now that is not at all the easiest way to add a bunch of decimals, right? Decimals are easier to work with than fractions, aren't they? Why would we ever take nice, easy to work with decimals and change them into terrible fractions? Well, they're trying to make sure we're really comfortable with how decimals and fractions relate. So really, the best way to add these would just be to, what do you tell me, when you add decimals, what do you got to focus on? What are you going to tell kids? What do you got to focus on when you add decimals? Like if I wrote it like this, would this be a good way to add the decimals?
No.
What's bad about that?
They're not lined up.
Yeah, you got to line up the decimals, huh? Because it's the place values that matter so much, which is why we spend all that time thinking about place value and different base systems. We have a base 10 system. Everything is about the place you're in, isn't it? So you would do it like this, huh? You would line up those decimals. So we'd get 8 to 11, 16, 10, 15. Anyway, 35.68. But that's not how they want me to do this problem. I'm just doing it ahead of time, getting the answer. That is the answer. But now, let's do it the way they really want me to do it. They want me to take 9.5 and first off change that to a fraction. How do you change 9.5 to a fraction?
You look at the decimal place.
Okay, yeah. And what is the decimal place there? Tenths, right? It's ending in the tenths place, isn't it? Yeah, how would we say that decimal? 9 5/10. Yeah, we'd say 9.5, really, huh? But if we wanted to say a fraction-y kind of thing, we would say 9 5/10. Right? I mean, that's another. You probably would just say 9.5 or 9.5. But yeah, 9 5/10 is also true. Okay, so what? Well, write this. They want me to write it as a fraction. How do I write 9 5/10 as a fraction?
You could write it as a mixed number and then make it an improper fraction.
Yeah, so you're saying make it 9, Cammie, you're saying 5/10, like a mixed number like that?
Yeah.
Right? That's true, isn't it? That's got to be right, doesn't it? 9 5/10, just like the name says, huh? And then we could just change that to a mixed number. I mean, it is mixed number. Change it to an improper fraction, as you said. So how do you change this mixed number into an improper fraction? Yeah, remember you multiply the bottom, add the top. So 9 times 10 is 90, add 5. 95 over 10. Hey, wait a minute. Could we have just grabbed that number and just put it over the whole 95 and just put it over 10 because it ends in the 10th place? Just straight. Looks like we could. We could skip this. Do you see that? Do you see what I'm observing? Just looking at the pattern. That's math. Math is just observing, predicting, describing patterns. So you see the pattern? You can just pretend that's a whole number, 95, and that's the top, and the bottom is whatever the ending place is. It's ending in the tenths. So would that work for this one? If we followed that same pattern, what would this one equal in the end? Yeah, I just take the whole number, 254, and put it over what? What's the name of the ending place? Tenths again, because it just goes one past the decimal. Is that right? How could I check it? Is that really true? What if I was to do it the more formal way and go, it's 25 and what? Mixed number? 4/10, and then I was to multiply 25 times 10? 250, add 4. Yeah, 254. See how this is working? So then, how about 0.78? Yeah, that one's easy. Bless you. That's 78 over 100, just straight, huh? Because it ends in the hundredths place. We good? Right? It ends in the tenths, hundredths. So 78 hundredths. Now, we're not reducing any of those fractions. We're just leaving them. So if you were to add these fractions, so now we want to add. So they want us to get. I believe. Let me double check. And then now they want us to add them here in this last part. They say, okay, now add them up. So I'm going to take the 95 over 10 and add to that the 254 over 10 and add to that the 78 over 100. Again, this is totally not the easy way to do this problem, but we're trying to make decimal fraction connections. So how would we add those? Simon?
You got to change the denominators to match.
Yeah, remember adding fractions, you got to get common denominators. Remember that whole thing? Yeah. So what would I have to make all the denominators become?
100.
Yeah, since that's the biggest one, huh? So what do I got to do to this first fraction? 10, top and bottom. Yeah, remember all that? So that would become 950 over 100. And then the middle one, same kind of thing, top and bottom by 10. So 2540 over 10. And the last one doesn't change because it's already got that denominator. Good. Oh, I forgot to make that 100 in the middle, huh? Here we go. So, yeah, so now they all have the same denominator, 100. So I can just add up the numbers. Now, what numbers am I going to add up? Well, 950 and 2540 and 78. Those are the numbers I'm going to add up, huh? Did you notice anything? Look at what I did when I did the decimals. Do you see how that forces them to line up? See how 547 are all above each other? 547 are all above each other. 008, 008. See how 9 and 5 and 0, 9 and 5. See how it forced the exact same lineup? See the beautiful connection between decimals and fractions and how they all work perfectly together? Right? That's why we're getting common denominators. That's why the decimal lineup is right. It's all about place value. It's just another way to show you. I mean, again, this is a terrible way to do a problem, but it's another way to show you how decimals and fractions fit together. So when you do all that, you're going to get 8, and here you're going to get 16, and that's 10. Can't even tell what that is now. 15, and then that's 3, 5, 6, 8. So I add all those up, and I get 3, 5, 6, 8 over what? 100. Now. And they say, write your answer in decimal form. So how do you take that number and convert it back to a decimal?
The decimal, 2 spots over.
Yeah, 2 spots, because that's what the dividing by 100 does, doesn't it? You write 3, 5, 6, 8, but it's divided by 100. So it's 3568 hundredths. So that means the decimal's got to be there. See how there's 2 zeros? It's got to go back 2 places. That always works, huh? Or the name. You can go by the name as well, 68 hundredths, which is exactly what we got, way easier way, just adding the decimals to begin with. Huh? So it's just showing the connection. So you'll see on the practice exam, what I would give you on the real exam is I would just ask you to convert one of these to a fraction, or some part of this, not this whole thing, but some part therein. So all those parts make sense? Questions on that? Try to solidify your decimal fraction connection. So the rules, I imagine you remember the rules. If I want to multiply 0.9 times 0.5, I want to multiply decimals by hand. Do you remember the rule for doing that? How do you do that by hand? I can line them up vertically if you want. That's better.
Don't you just multiply it and then once you get your answer, you move over how many decimals are all together?
So just like 5 times 9 is 45.
Yeah, and then you'll go like 1 decimal place for 5 and 1 decimal place for
Like
9.
1, 2, 1, 2. Like that? Exactly. Remember that? Remember those rules? Now you know what I'm going to say next, like what I always say. Why? Right? Because we want to know the reasons, not just the rules, right? We don't want to present to anybody that math is a bunch of rules. How boring. Math is a bunch of truth. Now, why is that true?
Isn't it like the same way, because you're multiplying the place value, it would be like if you multiplied like a 10 by a 10, you get 100.
Yeah.
Multiply a tenths place by a tenths place, you get 100s place.
Yeah, well said, exactly. And let's see it, and that's why they're going to have us actually make these as fractions and then multiply, is to see exactly what Cammie's saying. Yeah, let's take a look. That's exactly right. So let's take the 0.9 and make it a fraction. So what is 0.9 as a fraction? 9 tenths, right, because it ends in the tenths place. And 0.5, 5 tenths, exactly. And then when we multiply 9 tenths and 5 tenths, 5 times 9 is 45, 10 times 10 is 100, that 100 means 2 places back. So that's why we total that. That's what's going on there. Because, yeah, when you're multiplying those, they're both tenths. And that means it's 100, which is 2 places back. That's why that's true. That's why you count the places. Good? So just solidifying all those rules, given the reasons why. They want me to write those. I'm kind of unsure, to tell you the truth. But my guess, maybe this would probably be your guess too. Yeah, it's all I can think to do, right? It's not over 10. So that is a fraction that is the same as 205. Yeah, I guess that's for sure what they want. And what about the 0.03? How do we write 0.03 as a fraction? 3 over 100. Yeah, because he ends in the hundreds place, right? 2 places past. And then multiply, so let's multiply 205 over 1 times 3 over 100. So what do? You just multiply 3 times 2 is 6. 3 times 5 is 15. Am I going too quick there? So just multiply the numbers on the top. 3 times 200 is 600. And 3 times 5 is 15. And then on the bottom, 1 times 100 is just 100. And then how do we convert that to a decimal? You know, what does the dividing by 100 do again? 2 places, right? So 6.15. Yeah, so we're just emphasizing the same rule there on that. Right, because we did that one by decimal rule, which is easier. 0.03. You would just go 3 times 5 is 15, and 3 times 2 is 6, and then you'd move the decimal back 1, 2, 1, 2, same answer. That's because there's 100 on the bottom. All right, we've got it. So basically, they want us to, using estimation, to figure out where the decimal should be. So here, if you want to just write down part A, 5 times 827.21. What does it equal? It equals 413,605 with a decimal somewhere. That makes sense? They're telling me the digits, and they want me to figure out where the decimal goes. So can you do that? Can you put the decimal in there? How are we going to, how do we know where the decimal goes? Could we count?
There's
Yeah.
one number per decimal place.
Yeah, that's not going to always work, I don't think. I never thought about that before. Why do I think that would not always work? I mean, certainly it's right this time, but why would it not always work? I'm thinking it would. Okay, anyway, let's do this. So far, so good. You're right. You guys are just saying 2 decimal places back. You know, put the decimal right there. 2 decimal places back. You're totally right. When would it not work? Yeah, it would not work every time. Here's my counter example to that general philosophy. What if you had 50 times 0.1? Okay, now I'll tell you the answer is just 50 with a decimal somewhere. Well, yeah, what is the answer? The answer is, what is the answer, 5? Yeah, the answer is 5, right? Because it's 1/10 of 50, right? So the answer is 5. If I put the decimal back 1 place, I'm going to get the wrong answer, aren't I? You tracking with me? Am I making the issue more confusing?
Yeah. I guess because an instance like it, you have to assume that the 0 is still there because you know that the number you're multiplying by had a 0 that was dropped. So if you imagine that the 0 is still there, then that is what happened.
That's a good patch. Yeah, that's true. That would work. So I caution you about hey, just count the decimals and pop it in there, because of the fact that 50 times 0.1 is 0.5, and you might. It's not 0.5, I mean it's actually 5, and you might mess up. What Cammie's saying is if we just remember there was a 0 there that we're dropping, and then just always follow the rule of back 1, we'll be okay. That's true. But they won't always show it to you that way because it's not really 50, so they're not going to have a reason to show you 50. But yeah, if you intentionally remember that, that's true. So I'm just giving you a little caution. It's not quite so simple because this number might not just be a nice whole number. So instead, so what am I saying? Why am I saying it? Instead, what will always work and what I think they're wanting you to do is estimate. They're wanting you to just have a ballpark feel. They want you to look, say, hey, this is 5, and this is like about 800. Just be real roundy, rough with it. So just 5 times 800. So what is 5 times 800? About. Isn't it about 4,000? So putting the decimal here makes sense. If I put the decimal like, let me try it out some other places. If I put the decimal there, that can't be right. That's only 413. We took 800 5 times. How can it be 400, huh? Couldn't be that. You know what I mean? And then, or what if you had the decimal way back here? That'd be 41,000. How can 800 only 5 times be 41,000? No way. Does that make sense? So what they're trying to give you is a sense of the numbers here. So just by being reasonable, you're like, well, the decimal's got to go here because, let me get rid of that comma, because it's 4,000 something. 5 times 800 is about 4,000, isn't it? That's actually a very valuable thing. This isn't just like another goofy thing to do. It's really a very valuable thing to do, to have estimating techniques. What I've seen over my years of teaching statistics and all kinds of math classes where we do a lot of calculation, students will do their calculate all the time. So easy to hit a wrong button. We all do it. They'll hit a wrong button and they'll get an answer that's like, the decimal's like way back here. And then they'll select the wrong answer on a test. And I'm always wanting to say to them that can't. You want to have sensibleness about you. 800 5 times can't be 41, right? It can't be 41. You want to have that with you all. It's just a really good practice. You can build that into kids, especially because we do use so much technology now. Especially because we all use so much technology to do math and science. Engineers do, everybody does. And it's so easy to hit a wrong button really quick. You want to have about you a sense of the numbers, and then you'll find your little mistakes. So let's try that next one. Where was the decimals? Right there, huh? So let's try that next one. They're telling me the answer is right there. 19888,042. So figure out where the decimal goes. Just think about, and don't work hard. Estimating is supposed to be easy. So when you look at 88, just think 100. It's close to 100. Just be real rough with it. Make it super easy for yourself. It's supposed to be a quick, easy thing. Take that number. It's about 200. It's just really rough. It's just like 100 times 200, about. Right? That's about what those numbers are. So now what happens when you multiply anything by 100? It just pops the 2 zeros in the back? So it's going to take the 200, and it's going to pop 2 zeros in the back. So it's got to be about 20,000. Does that make sense, what I did there? So if it's got to be about then 19,888, you know where the decimal's going to go. Right there. 0.042, huh? Of course, your rule still worked. 1, 2, 3. But it won't always. I'm giving you a little caution with the zero thing. But, yeah, that's close to that. All right, how about this last one? How about dividing? So can you estimate this number and estimate that number? They're saying the answer is 721 with a decimal somewhere. Just pick something. What's 1.78 really close to? Pretty close to 2, huh? I'll put if you've seen a shaky equals, that means approximately equals. And so that's the bottom. What's the top close to? 130, 150, all those are fine. 100 is even okay if you want. If you want to even be really rough, just do 100. Any of those are fine. It doesn't really matter. Anything in the ballpark that's easy for you to work with. And so what's 100 divided by 2? 50. You might think, yeah, but this is 70. Yeah, but I don't think the decimal goes there, for example. I know for sure the decimal doesn't go there. It can't be 700. It's 50, or close to 50. It can't be 7.21. No way, it's close to 50. So we know. That's enough information, isn't it, to know the decimal must go there. Right? Even though I was really rough in my rounding, it's good enough, isn't it? All right, we will stop.